Welcome to Mathematics. Today we'll be solving the Pearson Edexcel IAL January 2023 paper of M1. In question 1, we are given that a train travels along a straight horizontal track between two stations. We are given that the train starts from rest at station A and accelerates uniformly for t seconds until it reaches a speed of 20 meters per second. Then it travels at this speed for 3 minutes before decelerating uniformly and coming to rest at station B. We are also given that the magnitude of acceleration is twice the magnitude of the deceleration. On part A, we have to draw the speed time graph for it. Since the acceleration is twice the deceleration, the time it accelerates will be half the time it decelerates. So if I start the graph, this value over here would be 20. The time is in seconds, so we have to convert this 3 minutes into seconds. So this part over here would be 180 seconds. So 3 into 60 seconds, 3 minutes, so 3 into 60 seconds, 180 seconds. Now the acceleration time will be half the deceleration time because the change in velocity would be the same. So the change in velocity over here, the change in speed over here is 20. The change in speed over here is 20. One is positive and one is negative. But what we are thinking about is the magnitude. So the change in velocity is 20. 20 is equal to the acceleration into the time it takes. Since the acceleration is twice the deceleration, it will be 2a. So the time will be t by 2 to still be 20. Since we know that a times t is 20, 2a divided by t by 2 would be again come out to be 80. So this is t seconds. This will be t plus 180. This part would be 2t. So this would be 2t. So t plus 180 plus 2t. So this would be 3t plus 180. Now we are given the distance between stations A and B. And we have to find the value of t. The total area under the graph will be equal to 4.8 kilometers. We have to convert it back into meters. So 4.8 into 10 cube to convert it into meters will be equal to the area under the graph. This is a trapezium. So half times the length of its parallel sides. So both of the red side, we have to add them together. So it would be 3t plus 180 plus 180, and the height of the trapezium is 20. From here, if we keep calculating it, we get 10 times 3t plus 360. We can divide both sides by 10 to get 4.8 into 10 square equal to 3t plus 360. 4.8 into 10 square is basically 480. So 3t would be equal to 480 minus 360. The value of t would come out to be 40. So t is 40. Now we have to find the acceleration during the first t seconds. In the first t seconds, the change in velocity is equal to 20, or we can use the initial speed to be 0, the final speed is 20, the time is 40. We have to find the acceleration. We can use v equals to u plus at. So 20 equals to 0 plus a into 40. the value of A would come out to be half meter per second square. Now in question 2, we are given that two particles A and B are moving in a straight line in opposite directions towards each other on a smooth horizontal surface when they collide directly. We are given that particle A has mass 3m kg and particle B has mass m kg. So we can draw a sketch for it before we go on to the questions. Particle A and particle B. Particle A has mass 3m kg and particle B has mass m kg. Now we are told that before the collision, both particles have a speed of 1.5 meter per second and they are moving toward each other. We know that from beforehand. So this is 1.5 meter square. This is 1.5 meter square. Meter per second. Now we are told that after the collision, the direction of motion A is unchanged. So A still moves rightwards. And we are told that the difference between the speed of A and the speed of B is 1 meter per second. So both of them must move to the right, because if B was moving to the left, A cannot move to the right. So B has to move to the right and B has to be faster than A. If A was moving faster than B towards the right, A would keep on pushing B until they were moving together, or it had pushed B fast enough to separate. So A would be moving slower. Since we are told that the difference is 1 meter per second. So if we consider this to be V, this will be V plus 1, or vice versa. If we take this to be V, this will be V minus 1. Now in part A, we have to find the speed of A immediately after the collision and the speed of B immediately after the collision. So for A, we can use the conservation of momentum. So if we consider the rightward motion to be positive, we'll have 3m times 1.5 plus m into minus 1.5. Since we are taking right to be positive, leftward motion will be negative. So this speed is leftward, so this will be negative. This will be equal to 3m times v plus m times v plus 1. So 4.5m minus 1.5m is equal to 3mv plus mv plus m. We can cut out all the m's. Since there are m's in all the terms, we'll get 4.5 minus 1.5, which is 3, equal to 3v plus m. 3v plus 1. 4v plus 1. So we'll have 4v equal to 2. V will be equal to 1 by 2. So the speed of P speed of A after collision is 1 by 2 meter per second. This is part 1. Part 2, the speed of B after collision is v plus 1, so half plus 1, this would be 3 by 2 meter per second. So speed of B after collision is 3 by 2 meter per second. Now in part B, we have to find in terms of m the magnitude of the impulse exerted on B. The magnitude exerted on A and B would have the same magnitude. The impulse on A would be leftward, the impulse on B would be rightward. We can do the calculation with any one of them. Since there is no change in the direction of motion of A, I'll do it with A. So the impulse would be m times v minus u. Considering it for A, the mass is 3m. The final velocity is half meter per second, and the initial velocity is 1.5 meter per second. So it would be 3m times minus 1. So this is minus 3m. Since we only need the magnitude of impulse would be 3m Newton seconds. In question 3, we are given that a particle P is moving with constant acceleration minus 4I plus j meter per second square. We are given at time t equals to 0, the velocity is 49 minus 5j. We have to find the speed of P at time t equals to 2 seconds. We know that v is the, if we don't need that here. We are given a constant acceleration. We are given the initial speed, which is 49 minus 5j. We are given the time. So we know the initial velocity, the acceleration, the time, and we have to find the final velocity. So we can use v equals to u plus at. The final velocity would be equal to the initial velocity, which is 14I minus 5j plus at. The acceleration is minus 4I plus j, and the time is 2. So the velocity is 14I minus 5j minus 8I plus 2j. The velocity vector at time t equals to 2 would be 6I minus 3j meter per second. We want the speed here, not the velocity. So we have to find the magnitude again. So 6 square plus 3 square. This would be 3 root 5 meter per second. Now in part B, we have to find the size of the angle between the direction of I and the direction of motion. So if I draw a sketch, this is j, this is I. 6I minus 3j will be 6 comma minus 3, so somewhere over here. So this is 6 and this is 3 or minus 3. We have to find this angle over here. This is the required angle. Since we know that this distance over here is 3 and this is 6, and we know that this is a right angle, we can use tan theta equals to 3 by 6. So theta would be tan inverse 3 by 6 or tan inverse half. So the value of theta would be 26.6 degrees. We are not given how many SFs to give to, so 3 would be the safest. Now we are given at time t equals to t seconds, P is moving in the direction of vector 2I minus 3j. So if it's moving parallel to 2I minus 3j, the velocity vector would be equal to 2ki minus 3kj. In this case, we know the initial velocity, we know the acceleration, the time is equal to capital T, which we have to find. We know the final velocity is in this form. So we can replace v with u plus at over here as well. The initial velocity is 49 minus 5j. The acceleration is equal to minus 4I plus j. So u plus, if we put it in u plus at, we'll get 4I minus 5j plus so 14i minus 5j plus minus 4i plus j times capital T. This is equal to 2ki minus 3kj. If we separate the I and j component, we'll get 14 minus 40i plus tj minus t minus 5j, which is equal to 2ki minus 3kj. We'll equate the I and j components separately. If we equate the I components, we get 14 minus 40 equal to 2k. From here we can get t in respect of k. So if I make t the subject over here, so we get 14 minus 2k equals to 40. So t is equal to 14 minus 2k by 4. Now we can put that over here. It would be better to make k the subject from here. So we can get 7 minus 2t equals to k, dividing both sides with 2. Now if I put it over here, so t minus 5 is equal to minus 3k. T minus 5 is equal to minus 3. We'll replace this over here instead of k. So t minus 5 equals to minus 21 plus 60. We'll move this t to the right and this minus 21 to the left. So we'll get 21 minus 5 is equal to 60 minus t. So 16 equals to 5t. The value of t would be 16 by 5, which is equal to 3.2. Now question 4 is about moments. We are given this diagram over here. We are told that this branch is a non-uniform rod with weight W, and that the distance from the point C to the center of mass is x meters. So if the point center of mass is somewhere over here, this distance is equal to x. We have to find the value of W, the weight of the rod, and the value of x, the distance. The things we are told as there is a force of 150 Newton vertically upwards at B. When there's a force of 150 Newton applied vertically upwards at B, so something like this, 150 Newton, it's on the point of tilting about D. So reaction at D at this point is 0. So reaction at D is 0. Reaction at C is maximum. If we devise the equation over there for that, the upward force will be equal to downward force. So reaction at C plus 0 plus 150 from this external force is equal to the weight. So reaction at C plus 150 is equal to the weight. Now we can also use moments about C. Since this is in equilibrium, we know this distance is x. If we consider moments about C, so W times x will give clockwise moment, and this 150 Newton force will provide the anti-clockwise moment. The distance between C and B would be 1.5 minus 0.24. So the entire rod except this part. This value is 1.26. So 1.26 into 150. So Wx is equal to 189. Now we are given that when a force of 225 Newton is applied vertically downwards at B, it's on the point of tilting about D. So force of 225 Newton downward at B. At that point, reaction at C is equal to 0 and reaction at D is maximum. So all of the upward force is provided by reaction at D in this case. So this is the case with 150 Newton up, and this is the case with 225 Newton down. We can do upward force equals to downward force again. In this case, reaction at the upward forces are the reaction at D. The upward force is reaction at D. There are no other upward forces. The downward forces are the weight of the rod and the 225 Newton force we are putting. And for this we can consider moment about D. This would be equal to 0. So basically clockwise moment is equal to anti-clockwise moment, the same as we did over here. If we consider about D in this case, the weight gives the anti-clockwise moment, while this external force gives the clockwise moment. This distance is 0.36. So we have 0.36 into 225 as the clockwise moment, and for the anti-clockwise moment we have weight. Now we have to find the distance of the center of mass from D as well. This distance. At first we can find the distance between C and D. We know this is 0.24, and this is 0.36. So in between over here we'll have 1.5 minus 0.24 minus 0.36. This would be 0.9 meters. So this part only would be 0.9 minus x, since the whole part is x plus this value, which is 0.9. This will be 0.9 minus x. So 0.9 minus x times W. So we have 81 over here, which is equal to 0.9 W minus Wx. From the previous part, we know that Wx is 189. So 81 equals to 0.9 W minus 189. So 0.9 W is equal to 81 plus 189, which is 270. The value of W is 270 divided by 0.9, which is 300. So the weight is 300 newtons. We can put that value of W over here. So 300x is equal to 189. X is equal to 189 divided by 300. So this is 0.63. By considering moments about C and D in two cases, we made this two equations unnecessary. But if we take moments about other points, we will need this. We'll have to use this. So we might have to use reaction at C is W minus 150 and reaction at D is W plus 225 if we consider moment about other points. So that's why I figured them out. So that's it for this question. We have the value of X and W both. Now in this question we are given 3 points P, Q and R which are on a horizontal road with PQR being a straight line. We are given the distance PQ which is 6x meters, the distance QR which is 5x meters. Then we are told a vehicle moves along this road from P to Q with constant acceleration. So this part in constant acceleration. At time t equals to 0, it has a velocity u meter per second. At t equals to 12, the vehicle passes Q with 2 u meter per second speed. We have to show that x is equal to 3u from this. So at P, this is u. At Q, the speed is 2u. The displacement is 6x and the time is 12. So we know the final velocity, the initial velocity, the time and the displacement. We have to show that the displacement is equal to 3u. So we have to find a relationship between x and u. So we'll involve the equation which has all 4 of them and does not contain a. So with this in this case it would be 6x the displacement, which is equal to, so this equation basically, so s equals to u plus v by 2t. In this case s is 6x, the initial velocity is u, the final velocity is 2u, and the time is 12. So if you divide both sides with 6, we'll have 1 over here, 2 over here. So 2 times 2 will cancel out again. So we'll have u plus 2u, which is 3u. So x is equal to 3u is shown over here. Now on part B, we are told that after the vehicle passes Q, so this point over here, it moves the next 5x meters at with an acceleration of 1.5 meter per second square and passes the last point is R with a speed of 3u. From that we have to find the value of u. So in this case the initial velocity is 2u, the final velocity is 3u. So initial velocity, final velocity, the displacement s is 5x, and we have to find, and we have the acceleration which is 1.5 meter per second square. We have to find the value of u. So we can use s equals to, sorry, we don't have the time over here, so we'll use v square equals to u square plus twice as. The final velocity is 3u, so square that. The initial velocity is 2u, square that, plus 2 times 1.5. The displacement is 5x. Instead of writing it 5x, we can use this over here. So 5 times 3u. So we'll have only one variable over here. If we had x, we'd have two different variables in one equation, so we couldn't solve it from there. So we'll straight up put 3u over here instead of x. On the left we have 9u square. Over here we have 4u square plus 45u. From here we can find a quadratic. So taking everything to the left, we have 5u square minus 45u equal to 0. We can take 5u common and have u minus 9. So the value of u can be equal to 0 or equal to 9. Since it's moving, it cannot be 0, so u must be equal to 9. And in part C, we have to find the distance traveled by the vehicle during the first 14 seconds after passing P. So after passing this point, 12 second it travels 6x meters. So the first 12 second displacement is 6x. So in the next 2 seconds, for the next 2 seconds we have the initial velocity, which is 2u. 2u is 18. We have the acceleration, which is 1.5. We have the time, which is 2. We need the displacement, so we can use s equals to ut plus half at square, since we don't need the final velocity or don't have it as well. So the displacement is 18 times 2 plus half into 1.5 into 2 square. This displacement over here would be 39. We can change this into 6 times 3u. The value of u is 9. So 6 into 3 into 9, which 162. So distance moved in the first 14 seconds is equal to 162 plus 39. This comes up with a value of 201 meters. Now in question 6, we are given that a boat is pulled along a river at a constant speed by 2 ropes. We are given that the banks of the river are parallel and the boat travels horizontally in a straight line. We are given that the tension in the first rope is 500 newtons. So this acting at 40 degrees. And that the second rope has a tension of p newtons at an angle of alpha, and that the resistance to motion of the boat as it moves through the water is a constant magnitude of 900 newtons. So from here we have to find alpha and p. The boat is traveling in this direction, so the resistance to motion would be in this direction and with a magnitude of 900 newton. If we resolve this two forces, for the 500 newton, we'll have an upward force of 500 sine 40 degrees and a rightward force of 500 cos 40 degrees. So the angle, so the component with which it subtends the angle is the cosine component, and the other one is the sine component. Now for this p newtons, we'll have a downward force of p sine alpha and a rightward force of p cos alpha. Since it's moving parallel to the river bank, this boat, the upward force and the downward force must be equal. So this is our first equation. P sine alpha is equal to 500 sine 40. Now our next equation, this is equation 1. Now our next equation would be that the rightward force and the leftward force are equal, because we are told that it's moving in a constant speed. A constant speed means acceleration is 0. If acceleration is 0, resultant force must be 0. So the rightward force must be equal to the leftward force. The rightward force is 500 cos 40 degree plus p cos alpha equal to 900. We can make p cos alpha the subject over here and have 900 minus 500 cos 40, since that's a constant as well. Now if we divide equation 1 by equation 2, we'll get P sine alpha by P cos alpha equal to 500 sine 40 divided by 900 minus 500 cos 40. Now we know the P will cancel out, and we know that sine alpha by cos alpha is tan alpha, so this would be tan alpha. So the value of alpha would be tan inverse 500 sine 40 divided by 900 minus 500 cos 40. From here we get the value of alpha to be 31.9 degree. Now we have to find the value of P. We can simply put the value of alpha in any of the equations. This one is easier. So I'll put P sine 31.9 degree. Instead of 31.9, it would be recommended to directly put in the calculator answer, which we get from calculating this. This is equal to 500 sine 40. So P is equal to 500 sine 40 by sine 31.9, and this comes out to be 608.7. 609 is decent enough. It's in 3 significant figures. So that's it for this question. Now in question 7, we have a question about an elevator. We are given a simple lift which works with a vertical cable. We are given that box Q is placed on the floor and box P is placed on top of box Q. We are given the cable is a light and inextensible, air resistance is negligible. We are given the tension in the cable, which is 42 by 5 mg, and we are given the acceleration, which is vertically upwards, so 2g by 5 vertically upwards. We have to find in terms of m the combined masses of box P and Q. The mass of the lift is m kg. The mass, and then we have to find the masses of P and Q combined. So mg plus, we can take on anything. We can write down capital M over here. And the tension is 42 by 5 mg upwards. So we know we have to find the unbalanced force over here. The unbalanced force is upwards since we are accelerating upwards. The unbalanced force would be 42 by 5 mg minus mg minus capital Mg, the combined mass of the boxes P and Q. This is equal to the total mass of the lift and the masses, so m small m plus capital M times its acceleration, which is 2g by 5. So 37 by 5 small mg minus capital Mg is equal to 2 times small m g by 5 plus 2 times capital Mg by 5. We can move the capital Mg to the right and the small mg to the left. We'll have 37 by 5 small mg minus 2 by 5 small mg is equal to 2 capital Mg by 5 plus capital Mg. On the left we'll get 7 small mg, and on the right we'll get 7 by 5 capital Mg. We can cancel out the g's and divide both sides with 7 by 5. On one side we'll get m, on the other we'll get 7 divided by 7 by 5. So capital M is 5m. So capital M is 5 times small m. Now we are given that during the motion of the lift, the force exerted on box P by box Q is 14 by 5 mg. So on P by Q, this is 14 by 5 mg. So we can draw the force diagram for the particle P or the box P. So the downward force on it is its own mass. We can consider it P. So the mass of the particle P, and the upward force on it is that force of 14 by 5 mg. And it's also accelerating with the same acceleration as the lift. So it also has an acceleration of 2g by 5. So it will also have an unbalanced force on the right, which is equal to mass times acceleration. So 14 by 5 mg minus pg is equals to p times 2g by 5. P is the mass of P. We can cancel out the g's. We can move this P to the right. We'll have 14 by 5 m equals to 2p by 5 plus p. So 7 by 5 p equal to 14 by 5 m. We can divide both sides with 7 by 5 to get 14 by 5 into 5 by 7. Dividing with 7 by 5 and multiplying with its reciprocal is the same. So we can do this. The 5's cancel out. This will come out to be 2m. So P is equal to 2m. Now moving on to the final question. We are given this inclined plane over here with a parcel of mass 2 kg, which is being pulled up a rough inclined plane with a constant force. The force has a magnitude of 18 newtons and acts at an angle of 40 degree to the plane. We are given that the plane is inclined at an angle of 30 degree with a coefficient of friction of 0.3. We have to find the acceleration of P. For the acceleration, we have to find the unbalanced force. It will be 18 cos 40 in this direction. We'll have friction mu r and the downward components of it, so 2g sine 30 in this direction. This will be 2g cos 30. Since we have the weight of this parcel acting with this being 30 degree. This angle is 90 minus 30. This whole angle is 90, so this is 30 degree. This is 2g cos 30, this is 2g sine 30. And on this side, we'll have the upward component of 18 newton, so 18 sine 40, and the normal contact force between the parcel and the plane. So from that we can find r easily. So r plus 18 sine 40 will be equal to 2g cos 30. So r would be 2g cos 30 minus 18 sine 40. We can put this in mu r. The value of mu is 0.3, and then we have 2g cos 30 minus 18 sine 40. So from there we can find the unbalanced force, which will be 18 cos 40 minus 2g sine 30 minus 0.3 times 2g cos 30. minus 18 sine 40. This is equals to the mass times the acceleration, so 2 times a. If we calculate the acceleration from this, so this term on the left divided by 2 would be equal to the acceleration. So the acceleration would be 1.18 meter per second square. Now we are given that points A and B lie on the slope, where AB, the distance is 5 meters and B is above A. We are given the particle P passes through A with speed 2 meter per second. We have to find the speed of P as it passes through B. So this could be point A and this could be point B. This is the displacement 5 meters. So we have the initial velocity, which is 2 meter per second. We have the acceleration, which is positive 1.18 meter per second squared. We have the displacement, which is 5 meters. We have to find the final velocity. In this case, we don't have the time, so we'll use v square equals to u square plus twice as. So v is equal to 2 square plus 2 times 1.18 times 5. It's better to use the direct calculator value you get for this acceleration instead of putting an approximation. So v would be root over 4 plus 2 into 1.18 times 5. From here we get a value of b, which is 3.9797, so 3.98 meter per second. Now we are told that the force of 18 Newton is removed at the instant P passes through B, and as a result P comes to rest at the point C. We have to determine whether P will remain at rest or it won't. So for P to remain at rest, the upward force and downward force must be balanced. So without friction, the downward force is 2g sine 30. There are no upward forces. So for this to be balanced, we'll have to put mu r upwards. Now the value of r will also change. R will now be equals to 2g cos 30. So mu r would be 0.3 times 2g cos 30. We have to find out if the maximum friction is greater than the downward force over here. So F downwards is equal to 2g sine 30, which is basically 2g times sine 30 is half, so this is equal to g. And maximum friction in this case will be 0.3 times 2g cos 30. This would come out 3 root 3 by 10g. 3 root 3 by 10 is smaller than 1, so the downward force is greater than the maximum friction. So the friction cannot support this, so we can write 2g sine 30 equals to 9.8. We can just put in the values over here now. This is approximately 5.09. So we can write then this is greater than the maximum friction. Put the values in brackets. We can put the values in brackets, and then we'll write the conclusion. So the particle will not remains stationary. If the maximum friction was greater than or equal to this, we'll write the statement that it will remain stationary. So if F downward is less than or equal to max friction, particle is stationary. You don't have to write this as an answer, this is just a note. And that's it for this paper.